Echolocations and Cetaceans by April Lakowski. So first I'm going to talk about what echolocation is. It's defined as the location of objects by echoes, and it's also known as biosonar. Lots of different species use echolocations, just a few: shrews, bats, and even orcas. So we ask ourselves, why is echolocation important? Cetaceans such as dolphins use it as a sensory sonar system, and it helps them to communicate and locate things in their environment. In many cases, dolphins will live in murky waters or real deep waters where it's almost completely black, and they can't rely on their eyesight. They have to use echolocation to be able to hunt and to survive. There's some things we know about echolocation and things that we're still researching. Some things we do know is that dolphins will swim around an object and look at it from different aspects and create an image. But what we don't know is how they put those images together to create a scenery or their environment. Using echolocation, dolphins can obtain information on the object's size, shape, distance, speed, direction, and even its internal structure. But it's not known how the dolphin puts together that information. I work at a park called Discovery Cove. It's part of SeaWorld, where people can come and interact with dolphins. And trainers have told me cases of when a dolphin will completely stop the interaction and just stare at one particular guest. And after trainers would ask these guests questions to try to figure out what was going on, they often responded that they had a pacemaker or a prosthetic leg. So the dolphins are recognizing that something internally is not what they're used to seeing or locating in this case. That just goes to show their ability to see internal structures. Now I'm going to talk about the process of echolocation. Just behind the dolphin's blowhole, behind their melon, exist small sacs filled with air. Using these sacs, dolphins can create high-pitched sounds. A dolphin will send out a sound or a click underwater. Once the sound reaches an object, it'll turn around and bounce back to the dolphin. The bounce back sounds will reach the dolphin in its lower mandible or jaw and move to the middle ear. Ultimately, they'll end up in the dolphin's brain to be interpreted. Now I'm going to go ahead and talk about some research I found on echolocation in dolphins. The first article I'm going to talk about is titled Echolocation in Dolphins with a Dolphin-Bat Comparison. I only focused on the dolphin portion though. The study was done by Withlow Awe in the Bahamas, and he started off the article talking about how dolphins have sophisticated auditory systems as well as a keen capability for echolocation. He went into how they emit high-intensity pulses and how these pulses are sent out from the melon and ultimately end up back in the lower jaw. But the really cool thing about his article was that he found echolocation can detect targets at ranges of 100 or more meters, so they can send out their pulses really far. And he found that they can discriminate different targets based on their shape, size, material composition, and internal structures. And in the study, he found different sounds or motions correlated with different behaviors. And just to name a few, if you've heard a dolphin make little whistles, he found that's correlated with contact with another dolphin or reunion. Some other ones, buzzes. If you hear dolphins make buzzes, those were correlated with pursuit or herding. Tail slaps or non-vocal sounds sometimes showed aggression towards other dolphins. And then the echolocation clicks, he found that correlated with foraging and feeding. So he found basically that dolphins use echolocation mainly for their hunting. The next study I read about was called recognition and discrimination of human actions across the senses of echolocation and vision in the bottlenose dolphin. This study was performed by the University of Southern Mississippi and the Institute for Marine Mammals, and they tested the ability of bottlenose dolphins to use echolocation to recognize behaviors by trainers underwater. They used 3 female dolphins from the Marine Life Oceanarium, and each dolphin had previously learned to discriminate and correctly respond to human movements produced above water, but never had they been exposed to these same movements underwater. 5 target movements were selected. They used a bow movement, which informed the dolphin to leap above the water. They used a hula movement, which informed the dolphin to position itself vertically out of the water and spin in a circle. They used the bubbles movement, which asked the dolphin to go underwater and blow bubbles out of its blowhole. They used the yes movement, which instructed the dolphin to just nod its head as if it was answering a question with a yes. And lastly, a wave movement, which informed the dolphin to move its pectoral fin back and forth as if it was waving hello or goodbye. So once the dolphins were desensitized to the screen, they were presented with underwater movements with only a transparent screen separating the trainer and the dolphin, and this gave them the ability to use their vision to recognize the movements just as they would in the air. Each dolphin quickly learned to respond correctly to the human's underwater movements. All 3 dolphins achieved 90 to 100%. So after they demonstrated that they could reliably interpret underwater movements visually, they began to try to get them to use their echolocation. So to do this, they slowly darkened the screen until it was completely opaque, and this allowed the dolphins to know that there were still movements being produced behind the screen. And the dolphins did learn to use their echolocation rather than vision during this task. The set of results you're looking at right now are from the above water behaviors. Once I calculated it, you can see that they scored 98.7% correctly. The only thing they messed up on was wave and yes. The same dolphin messed up on those 2 behaviors. The second set of results you're looking at here are for the 3 dolphins when using echolocation. They got an overall score of 78%. They didn't do overall as well, but if you look, the things they messed up on a lot were the wave and the yes. They pretty much got 100% with the bow, bubbles, and the hula as they did when using their vision. So even though the second set of scores are a little lower, I think they're pretty good considering the dolphins were presented with this new unfamiliar situation and they didn't have a lot of time to desensitize to it. As I said, they messed up on waves and yeses, and unfortunately the article didn't specify how they were asked these behaviors, but as mentioned, I work at Discovery Cove, and at Discovery Cove, how we ask our dolphins to do a yes motion is you basically just lean forward over the dolphin and it'll say yes. So I don't know how they ask, but if it's any way like we do, then that could be a reason why they messed up on those behaviors a lot, because that might not be easily recognizable underwater. The last article I used for my research was an article done by the New College of Florida and the University of Hawaii, and they reviewed echolocation waveforms from different angles of an object. They included an overview of dolphins' echolocation systems, and then went into how they use their echolocation to extract features of specific objects. In these results, you can see that the dolphins were presented with 3 similar objects. They used a cube, a rectangular prism, and a pyramid. And you can see that there's 3 different wavelengths here, and each of these different wavelengths represents a different object. So you can see how the dolphins use echolocation to recognize just slight differences. With all the research the article did on object features, it didn't provide any proof of dolphins having the ability to create holistic shape information. That's one thing I really wanted to do research on, was the dolphin's ability to transfer images from one dolphin to another holographically. So just to sum things up here, I think that all the articles were pretty well done, and for the most part, they provided me with helpful information to my chosen topic. There were some flaws in them, like I mentioned earlier. I wish some or any of the articles had done some more research on holographic echolocation rather than just how the signals are used and received by the dolphins. This question still needs a lot of research, and in my opinion would be really neat to learn about. I don't know why they aren't doing more research on it. My favorite article was the one done using signals underwater. I could relate to this article because of my workplace, and I think the experiment could be repeated with some slight corrections, and it would provide us with more information on dolphins and how they use their echolocation. So that's my presentation on echolocation and cetaceans. I hope you all learned something new and fun, and thanks for watching.